You flip a coin 5 times. Find the probability that it lands on tails exactly 3 times. This is the class of a problem in which we are asked to discuss the probability of X number of successes out of n trials. What I mean by that? We have selected a coin, we have flipped a coin 5 times, and we want to see what is the chance that it will land on tails exactly 3 times. And I told you when I was discussing the concept of a binomial probability distribution, I told you what is the central problem in a binomial probability problems. What is the central question? The central question is to find the probability of X successes out of n trials. I will explain that, what I mean by that, right? So first, before we even try to compute the probability, we need to make sure that this experiment is a binomial experiment. That's what we need to confirm. Otherwise, we cannot apply the theory that we have already studied. So see, is it a binomial or not? Let's see that. So in order for a distribution to be a binomial distribution, it has to have 4 conditions. Number 1, it has to have a finite number of trials. Number of trials here, n is finite number of trials. Our number of trials is 5, and 5 is a finite. Why the number of trial is 5? Because we flip the coin 5 times. Right? The number of trials are finite. Number 2, there are only 2 possible outcomes. 2 possible outcome only. You can see very easily 2 possible outcomes. Either the coin lands on tails or it doesn't land on tail, which means the lands on heads, right? Only 2 possible outcomes. Number 3, there is a constant probability of success. We have a constant probability of success. And you remember that a constant probability is represented by a small letter p, and that is a 50%. When you flip a coin, there is a 50% chance the coin will land on tails, and there is a 50% chance it will land on heads. So the probability of success is constant. In this situation, our success will occur when our coin lands on tails. That's our success. Right? And if the coin lands on heads, it will be our failure in this particular problem. Number 4, what is the 4th condition? The 4th condition was the trials are independent. Trials are independent. What I mean by the trials are independent? If the probability in one trial is not affected, is not affected what happened in the previous trial, then we say the trials are independent. And you flip the coin, you'd flip the coin 5 times, right? What happens in the 3rd flip has nothing to do what will happen in the 4th flip. So each flip is independent. So all the conditions are met for the binomial experiment. So this experiment, this example we're dealing is really a binomial experiment. Now, as we have decided, as we have confirmed that this is a binomial experiment, now we can apply the computation. How we are going to compute the probability that our coin lands exactly 3 times a tail. There are 3 options available. We can use technology. We can use table, or we can use formula. I will try to show you these things one by one. First, we're going to use technology. And for the technology, we're going to use Microsoft Excel, right? We're going to use Excel. And the function that we're going to use is called binom.dist.range. That's the function we're going to use, right? That's a function we're going to use. It will ask us what is n. Our n is 5. It will ask us what is your number of success? How many times you want to be successful? I want to be successful 3 times. That's what I'm looking for, right? And he will ask you what is the probability of success? It's 0.5. These are the things it will ask you, and I will plug this in Microsoft Excel, and Excel will give me. So actually what I'm finding the probability that X is exactly equal to 3. What is the probability that my coin lands on tail exactly 3 times? So how we are going to do that? Let's see. Let's move to the Microsoft Excel. Okay, we are in Microsoft Excel, and now what we're going to do, we're going to show you how we're going to compute that. So in order to insert the formulas in Microsoft Excel, you will go to the formulas, more function, and a statistical function, and all these formulas are written in alphabetic order, right? Our function was binom.dst Look at that, that's the formula. You click on this one, and now he is asking you different things. He's asking how many trials are there. There were n. He's asking for n, number of trials, 5. What is the probability of success in each trial? It was 0.5. And asking how many times you want to be successful, and this is the x he's asking for, and he's asking for x, and we want to be successful 3 times, right? When we are dealing with a range, he asks for the first number and the second number, but in our situation it's not a range, it's a single number. We are looking for the probability that the coin lands on exactly 3 times. It's not like a range, so you don't fill the second one. Don't fill the second one. So you just click on that, and here is the answer: 0.31312, 0.312 or 5 or 0.313 maybe, if you round it to the 3 decimal places. So 0.313. So our answer comes out to be 0. So the probability of success comes out to be 0.313. That's the probability of success by using Microsoft Excel. So in the second part, he is asking what is the probability that the coin will land on tail at the most 3 times. So this word, this at most, is important, right? This at most, this is important. At most mean we want to find out the probability. We want to find out the probability that x at the most is less than or equal to 3. At the most 3 mean x is less than or equal to 3. So how we're going to deal with this one? We're going to again use Microsoft Excel. Let's see that. So in this situation, what we're going to do, let's clear it. Again, we are going to teach you how to insert the formula. Look at once again, formulas, more function, statistical, and binom.dist.range. Same stuff. We have a 5 number of trials. The probability of success is the same, 0.5. The number first. Now he's asking for the at the most 3. What is it? What I mean by at the most 3? The probability of success can be 0, it can be 1, it can be 2, or it can be 3, but it cannot be more than 3. So I will start the concept of the range here. I will start the first number, which is 0, and I will write the second number, which is a 3 here, and the answer comes out to be here 0.8125. So this is 0.813. 0.813. So our answer here comes out to be 0.813. In the third part, he is asking what is the probability that the coin will land on tail at least 3 times. What you need to understand, what does this mean, at least 3 times? It means 3 or more. So he is asking here the probability of x is greater than or equal to 3. That is what I mean by at least 3. So again, we are going to use Microsoft Excel for this purpose. Let's see how we're going to do that. Now, I again show you, although I could have done just a change in the formula, but I'm showing you this once again. Formulas, more functions, statistical function, and binom.dst.range. He's asking the same thing. Number of trials is 5. Probability of the success is 0.5, 0.5, the same thing. Now he's asking the range. Now our range is 3 or more. So it will be 3, 4, and 5. We can't go beyond 5 because we flip the coin 5 times, right? So it will be starting from 3, and the second number will be 5. So if you do that, the answer will be here. It's a 0.5. It's a 0.5. So the answer comes out to be 0.5. So let's write that. This is the probability. It's more than 3 is 0.5. So we are back to the part number 1. Previously we have used technology, which is a Microsoft Excel, to compute the probability, but now I'm teaching you how to use the table. This is your second option, right? So we have a table which is called a binomial probability distribution table. How this table look like, let me show you. This table is this. This is the binomial probability distribution table. Sometimes people call it table 7, binomial probability. That's the formula which I will teach you in the future videos how this formula works. But in order to use this particular table, you need to know these things. You need to know n. You need to know n, right? You need to look at this n. N is here. You need to know P, and you need to know X. These are the things you need to know. So in this situation, in our situation, n is 5, the probability of success is 0.5, and we want to be successful exactly 3 times. So our X is 3. So what you're going to do now, look at this. This is P. Look at that. This is X, right? What we're going to do, we're going to first go to the n5. This is our n5. Please pay attention, right? For out of these n5, we're looking for x is equal to 3. This is x is equal to 3, right? And what we're going to do at the top, you're going to look for p equals to 0.5 because p is 0.5. Here p is 0.5. So what you are going to do, you're going to go across like this. I have to be careful. You have to go across like this, and we have to go down like this. At the intersection of these two values, here is the value, which is 0.312. 0.312. This is the value which we are looking for. Let's plug in the value here. So use of the table, we get the probability of x when x is equal to 3 is 0.312. There is a round of situation take place. Otherwise, the answer is the same. Now let's move to the second part and see how we can use table to perform the same computation to get the same answer. So we're using the table. So the probability that x is less than or equal to 3, that will be equal to the probability that this number of successes is less than or equal to 3, that is equal to probability x is equal to 0, or the probability that x is equal to 1, or the probability that not a probability here, remove this, that x is equal to 2, or x is equal to 3. Now what happened basically here, these are all mutually exclusive events. These cannot happen at the same time. So we can apply the additional rules of probability. The probability of x is equal to 0 plus the probability of x is equal to 1 plus the probability of x is equal to 2 plus the probability of x is equal to 3. Now we can use the table and we can plug in the values by using the table. And where are the values? The values are here. This is the probability when x is equal to 0. This is the probability when x is equal to 1. This is the probability when x is equal to 2. This is the probability when x is equal to 3. So if you add all these values, and you have to believe me, this will turn out to be somewhere 0.313, or approximately it's nearly equal to 0.13 if you add all these values, right? So if you add all these probabilities, the answer will come out to be 0.813. I hope you understand this computation. Thanks for watching.